Why is it that there are only 3 arresting wires on the new USS Gerald R. Ford aircraft carrier compared to 4 arresting wires on the older Nimitz-class carriers? Isn't having 4 arresting wires safer after all? Well, let's find out. Traditionally, earlier produced Nimitz-class carriers had 4 arresting wires, spaced roughly 50 feet apart. Usually, the pilot aims for the 3rd wire, as it's the safest and the most effective target. The first wire is deemed too dangerous, as it's too close to the edge of the deck, and if the plane comes in too low for the first wire, the aircraft could easily crash into the stern of the carrier. Nevertheless, the wire is still there for an accidental snag. Catching the 2nd and the 4th arresting wires are acceptable, but according to at least one source, pilots need to consistently catch the 3rd wire in order to move up through the ranks. In order to hit the 3rd wire, the pilot needs to approach the deck at exactly the right angle, but aligning the aircraft with a moving ship is not an easy endeavor. For this reason, the pilot relies on both landing signal officers who help with guiding the pilot through radio communications and the Fresnel lens optical landing system, known as the lens. The lens consists of a horizontal row of green lights, known as datum lights, used as a reference, and an amber light, called the meatball, that travels up and down along a vertical column. This lens system is mounted on a gyroscopically stabilized platform to counteract the ship's movements. The lens focuses the amber light into narrow beams that are directed into the sky at various angles. The pilot will be paying close attention to the meatball, as it indicates the airplane's angle of approach in reference to the flight deck. If the meatball is above the datum lights, the plane is approaching too high. If the meatball is below the datum lights, the aircraft is too low. And finally, if the meatball is in line with the row of green lights, the plane is on target. While earlier arresting wire systems relied on running cables through pulleys that were attached to sandbags, modern systems are much more complex. Nimitz-class carriers rely on the Mk7 hydraulic arresting gear system, which is more than 60 years old. A modern Mk7 Mod 3 system can safely bring a 50,000-pound aircraft moving at 130 knots to a full stop in 2 seconds over a distance of 344 feet. It may appear that the arresting cable systems are pretty simple, as all you see are the cables on the deck. But below the deck, there's a complex mechanism of pulleys, cables, and hydraulic cylinders. To put it simply, the more arresting cables you have on the flight deck, the more equipment you need below the deck, which is expensive to build and maintain. For this reason, starting with USS Ronald Reagan and followed by USS George H.W. Bush and USS Gerald R. Ford aircraft carriers, the US Navy started using a 3-wire design instead of 4 to save money on installation and maintenance of arresting gear. So this was a cost-cutting measure, but it was only allowed to happen due to an additional piece of equipment that allowed a 3-wire system to perform as effectively as a 4-wire system without compromising safety. More on that piece of equipment in just a minute. The new 3-wire system relies on polycore cables, which are designed to withstand more traps than steel cables. In this new 3-wire design, the 2nd wire is the new hit wire, and it's located at the same spot as the 3rd wire sits in the older 4-wire configurations. Additionally, instead of 4 arresting gear engines and 1 barricade engine, the setup switched to just 4 arresting gear engines, with 2 of them being interchangeable as barricade engines. This modification greatly freed up space below the deck and reduced maintenance costs. Finally, let's talk about the new piece of equipment that allowed the US Navy to go from 4 arresting wires down to just 3. It's the improved Fresnel lens optical landing system, with 12 fiber optic cells that indicate the glide slope to the pilot at about twice the sensitivity that the older optical landing systems did. Because of this, it is now possible to accurately reference the lens as far out as a mile, and the pilot has tighter control of the glide slope, which makes it significantly easier to catch the hit wire. This system was first tested in 1997 aboard USS George Washington, and every deploying American aircraft carrier since 2004 has had this system. As a result of this improved lens system, all new aircraft carriers commissioned in the new millennia went from 4 arresting wires down to 3, including USS Gerald R. Ford. And yes, USS Gerald R. Ford does use a troublesome advanced arresting gear system, not the Mk7 system, but that's a topic for another video.